Yesterday we looked at dividing polynomials with long division. Today we're going to look at another way you can do it called synthetic division. Uh, Up on the screen here, we'll do the same problem both ways so you can kind of see it. And then once we've learned both ways, you can kind of go through and decide which way you think you like the best. The long division route was the same as we did yesterday using a similar method that you learned back in grade school. So you put what you're dividing by, in this case, z minus 4, out in front. What you're dividing goes in the division bar. And then what you're looking at doing is seeing how many times does this first term go into this first term. In this problem, that would be z. If you take z squared divided by z, you'd get 1z left over. Now you kind of distribute that back through to both of these terms here. And you end up with z times z is z squared. Z times negative 4 would be minus 4z. Now what we do is subtract that. These should always cancel out because if you got z squared minus z squared, it's going to be 0. And then you got to subtract the next two terms. 2z minus a negative 4z, that would turn into 6z because you're really adding if you're subtracting a negative. Bring down the next term and repeat the process. So now we want to see if we take z again and divide it into 6z, what do we get? So 6z divided by z would be 6. So we have plus 6. Again, take that and distribute it back through here. So we'd have 6z. 6 times negative 4 would be negative 24. Now we're going to subtract this again. These will always cancel out because they're the same. If you take negative 24 minus a negative 24, that's like adding again. So that would also cancel out, leaving us with 0 as our remainder. So whatever you have up here now becomes your answer if there's no remainder. So the answer here would be z plus 6 is what you'd get. Okay, that's the long division way. We're going to look today at another way you can do these problems called synthetic division. In synthetic division, we start by taking whatever you're dividing by here, z minus 4, setting it equal to 0 and solving. If we set this equal to 0, we get 4. What we're going to do then is take that number, and we're going to put it over in a little box here, just to kind of keep in mind that that's the number that we're going to be using to divide. Then what you're going to do is you're going to take all the coefficients. Coefficients mean the numbers in front of these variables up in top. So we're going to take the number 1, because there's a 1 in front of the z squared, 2, and negative 24, and write those numbers out after this. So we got 1, 2, and negative 24. Those are the numbers that we got just from right up here. So we're just going to use those numbers. All right. Now what you're going to do is draw a line, because our answer is going to be below this line here. The first step in synthetic division is just to bring down, you just always bring down the first number, 1. Okay. Now we're going to take what we had here, this number right here, and instead of dividing, since we solved it for 0, we're actually going to multiply. So we're going to take our number here, multiply it with our number there, and write the result in the next column. So if we take 4 times 1, the result is going to be 4. All right, now after you've dropped down this first number, the rest of these we're going to add together. So we're going to take 2 plus 4 and see what the result is. The real result would be 6. Now we're going to repeat that process again. We're going to multiply number here with the number here and write the result right there. So if you take 4 times 6, the result would be 24. Again, you're going to add these columns together. If you add negative 24 and 24, the result is 0. Okay, just like we ended up with 0 when we did the long division problem over here, we also end up with a 0 here. This is our remainder. And in here, we didn't get a remainder. So this one does not have a remainder. These other numbers here then, we have to put back in polynomial form. They're the coefficients. So we need to put them back in a form that looks like a polynomial. the first number after the remainder is our constant term. It's like z to the 0 power. Z to the anything to the 0 power is 1, so we don't need to write z to the 0 power. The next one up from that is going to be z to the power of 1. And there'd be a 1 in front of it. Now, again, if there's 1s, you don't have to write those. So the 1 in front, you don't need to write. Also, if there's an exponent of 1, you don't need to write that either. So the answer we get is z plus 6. Same answer we got using long division. So that's called synthetic division. It's kind of a nice method. It works a little quicker. There are some things where you got to tweak it a little, as you'll see as we go, but it's kind of a quick method because you can multiply rather than going through the whole long division process. So let's try it on some other ones, see what you get. All right, let's try example 1. So first step again, you want to take what you're dividing by, x plus 3 in this problem, set it equal to 0 and see what you get. -3. That number we're going to put over here in a box. Now we're going to bring down all our coefficients. 2, 3, -4, because we got a minus sign here, and 15. Put a line on there. All right, first step, always just bring down the first number. Write it in your answer. That's always going to be part of your answer. Now comes the multiplication process again. We're going to multiply this number with the bottom number we got down there and write the result in the next column. So if we take -3 times 2, the result is -6. Okay. Now as you're going down, every time you add the columns. So if we add up the columns, 3 plus -6 is -3. All right, repeat that multiplication process now. So next time we're going to multiply -3 times 3, write the result there. So negative times the negative should be positive, so we get +9. Add the columns again. If we add the columns, we get 5. Okay, multiply again. -3 times 5 is -15. Add them up, we get 0. This last one here, this is always your remainder. So again, this problem, we did not end up with the remainder. Sometimes you don't end up with the remainder, that's fine. We'll talk about what happens if you do. All right, now we got to write our answer out though. These are the coefficients here for our answer. So the first one is going to be our constant term. Okay, just like here, the first term is a constant term. So the first part of our answer is 5. The next term up from that is going to have a power of x. So it'd be -3x. The next term up from that should be an x squared term. So we get 2x squared. And you just keep increasing the power of x until you run out of numbers. That then, right there, is our answer. Okay, now some of you may be thinking, well, Mr. Johnson, how come we don't have a power of 3 on our answer? Well, if we're dividing a polynomial where the biggest degree is 3 by another polynomial where the biggest degree is 1, you're going to go down a power in your answer when you divide. So the biggest one now is going to be a power of 2. All right, let's look at another one. Let's try number 2 out. All right, if you look at problem 2, we are also going to do some synthetic division on this one. Again, put what you're dividing by equal to 0. Looks like -2 is our number in the box this time. Okay, and write your coefficients. Now, notice something on this one. We talked about this when we did long division 2. Look at our degrees of x here. 4, 3, 1, 0. What happened here? We're missing one, right? We don't have every power accounted for. There's no degree of 2 in here. So if you are missing a degree when you're writing your coefficients of 6, 15, we don't have a power of 2 listed in our polynomial, you need to put a 0. Anytime there's a missing power, there's like a 0 in front of it. It's like +0x squared. So you got to write a 0 in there anytime a degree is missing. The next coefficient would be -28 and -6. So if there's ever a missing degree, write in a 0. Otherwise, synthetic division or line division doesn't work out. All right, let's repeat the process and kind of see what we get. Bring down the first number, 6, multiply, negative 2 times 6 is negative 12. Add, we get 3. Multiply again, negative 2 times 3 is going to be negative 6. Added with 0 is still negative 6. Multiply again. If we take our number up here, negative 2 times the negative 6, 2 negatives is going to make positive 12. Add again, you get negative 16. Multiply 2 negatives again is going to produce a positive number, 32. Add, and we get 26. All right, this time we did get a remainder. Okay, if you have a remainder, we need to account for that when we write our answer. We'll come back to it in a second. First off, let's write our polynomials here. So the first one after the remainder, negative 16, that's going to be our constant term. The next one up is going to be x to the first power, then x squared. The next one should be x cubed, and we ran out of terms, so that's that part of the answer. But we did have a remainder. So like we did with long division, if you have a remainder, you add the remainder on, and you divide it by what we were dividing by in the problem. In this problem, we were dividing by x plus 2. So in our answer then, we write x plus 2 under our remainder. And that polynomial then becomes our answer. So anytime you get a remainder, divide by it. Okay. We're going to take a look tomorrow what happens when you have some numbers where you end up dividing. So we'll look at ones like 3 and 4 tomorrow when you come back to class.